By 2050, a Japanese construction company plans to carry passengers 36,000 kilometers straight up. No rocket required. Not a concept sketch. Not science fiction. Obayashi Corporation has a timeline, a budget framework, and as of 2023, a working prototype tested in orbit. Here's how it works. A cable, thinner than a garden hose, anchored to the ocean surface and extending past geostationary orbit. Climber vehicles ride that cable at 200 kilometers per hour. The trip to the station takes roughly 7.5 days. In 2018, Shizuoka University launched the STARS-Me experiment aboard the International Space Station. 2 tiny CubeSats connected by a 10-meter steel cable. A small motorized container moved between them. It was the first space elevator movement test ever conducted in actual orbit. The main obstacle has always been material. Steel snaps under its own weight at that length. Kevlar fails. The only known candidate is carbon nanotube fiber, a material 100 times stronger than steel at 1/6 the weight. But no lab on Earth has produced a strand longer than a few centimeters that maintains full structural integrity. This is really about cost. Launching 1 kilogram into orbit on a conventional rocket runs between $2,500 and $5,000, depending on the vehicle. A space elevator could bring that number below $200 per kilogram. That single change reshapes everything: satellite deployment, lunar supply chains, deep space mission construction. Think of it this way. The Panama Canal didn't just move ships, it restructured global trade. A space elevator would do the same thing for orbit. Permanent manufacturing stations, affordable lunar transit, construction yards for Mars-bound vehicles assembled in zero gravity instead of launched piece by piece from the ground. The International Space Station took over 40 launches to build. An elevator changes that math permanently. But here's what most people miss. Japan isn't alone anymore. In 2024, the International Academy of Astronautics updated its roadmap for space elevator feasibility. China's National Space Administration has funded tether dynamics research at Tsinghua University, and a team at the University of British Columbia published a peer-reviewed design for a partial elevator, a space line suspended from geostationary orbit that dips into the upper atmosphere, cutting launch energy requirements by more than a third. The engineering race has quietly started. Rockets work. They've carried us for 70 years, but they burn fuel to fight gravity every single second of the climb. An elevator doesn't fight gravity. It balances on it. The first country to build one doesn't just reach space cheaper, it owns the road. And Japan broke ground on the engineering 15 years ago. Follow for more space science.